The third thing we're going to use in coordinate geometry very often is the midpoint. The midpoint of a segment, we know, is the point on a segment that divides the segment into two equal parts. So if I want to find the midpoint of 2 points of an endpoint here, I've got A and B. And what I want to do is I want to take my points, and I'm going to use a capital M for my midpoint. And notice that this is different than the other two formulas because this is an ordered pair. I get an average of the x's and an average of the y's, and it gives me a point, not a length, but a point. So if I want to find the midpoint of each segment, the very first thing I'm going to do is I'm going to write down my formula. So m equals x1 plus x2 over 2, comma, again, this is an ordered pair, y1 plus y2 over 2. So plugging my numbers in, 5 plus 0 divided by 2, 4 plus 4 divided by 2. So the midpoint of this segment is going to be 5/2, 4. So if I wanted to find the point that was right in the middle of the segment, I would know exactly where that point would lie. If I want the midpoint of OP, again, I'm going to write my formula. x1 plus x2 over 2, y1 plus y2 over 2. Plugging my numbers in this time. -3 plus 3 over 2, -2 plus 3 over 2. So m is going to end up being 0, 1/2. Again, finding the middle of my segment. Number 13. Let's try 13. Well, let's do this one here. So my my midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So plugging my numbers in, -3 plus 3 divided by 2, 6 plus -3 divided by 2. My midpoint then is going to be 0, comma, 3/2. Our last one, again, always writing our formulas. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Plugging my numbers in, 3 plus -2 divided by 2, -8 plus -5 divided by 2. So my midpoint is going to give me 1/2, and 8 plus -5 is going to give me -13. So I can just leave this as -13/2 if I want, or I can turn it into a decimal if I'd like as well. Number 15 is an interesting question, and this can be solved algebraically. They give me the midpoint, they give me point A, I'm looking for the other endpoint. So there's a couple of different ways that we can do this. We can do this by thinking about equal distances between our points. So if I start at A, and I'm at 4, 0, and I translate to M, which is -1, 7, and I'm looking for what is the B, what is that coordinate? So I can think about translations, and I can think about how did I get from 4 to -1? How did I get from 0 to 7? Well, to get from 4 to -1, I had to go down 5, so -5. To get from 0 to 7, I had to add 7. So now I apply that same exact translation to get to B. So if I have -1 and I want to subtract 5 more, I'm now at -6. If I'm at 7 and I want to add 7 more, I'm now at 14. So my new point is going to be negative 6, 14. I can do this also by using slopes. So let's try number 16 graphically. So in number 16, my point is negative 9, 4. That's my R. My midpoint is negative 3, 5. Here's my midpoint. And I'm looking for where is that coordinate of Q, trying to find Q. So one thing I can do is I can use my slope. So if I think about my rise over run, my slope here is up 1 over 1, 2, 3, 4, 5, 6. So now, 1 and a 6. So now I do the same thing. Up 1 over 1, 2, 3, 4, 5, 6. So my point Q, again, 1 to 6, using that same idea here. So now my point Q is 3, 6.